In question 2 of our series, where we find the derivative of parametric equations, we're asked if x is equal to t to the power of 3 plus 1 and y is equal to the square root of 8t plus 1, find dy over dx at the point 2 and 3. We learned in question 1 that to find the derivative of parametric equations, we use dy over dx is equal to the derivative of y with respect to t and the derivative of x with respect to t. So I'm going to start by finding the derivative of the easier equation, which is x is equal to t to the power of 3 plus 1. If I find the derivative implicitly, I end up with dx over dt is equal to 3t to the power of 2. This 1 becomes a 0. So I just found this part. Now I need to find this part. So I have y is equal to the square root, which I'll write it out as 8t plus 1 all raised to a half. Now, this half will go to the front, where we have 1 over 2 times 8t plus 1. And don't forget to subtract the exponent by 1. So half minus 1 is negative half. And we find the derivative of this expression. 8t plus 1 gives us simply 8. 8 over half is 4. And this part of the expression can be written as, without this negative exponent, the square root of 8t plus 1. So now I have both components. My answer is dy over dx is equal to 4 over the square root of 8t plus 1 over what I found earlier for dx over dt, which is 3t squared. They want to find the rate of change at the point 2 and 3. So at this point, I will substitute this 2 into any of these two equations. And by substituting one of these coordinates into any one of these equations, I can isolate for t. In case you're confused, here's what I mean. So let's say I substitute this point 2 into x. I end up with 2 is equal to t to the power of 3 plus 1. If I bring this 1 over, I end up with 2 minus 1, which is 1. And therefore, t is equal to 1. Now, if I substitute this 1 into here, I'll end up with 8 times 1, which is 8 plus 1, and the square root of 9 is 3. So that confirms it's correct. I can now take this 1 and place it wherever I see the t in my derivative, where I have 4 over 8 times 1 plus 1 is 9. The square root of 9 is 3. So that's the numerator. In the denominator, we have 3 times 1 to the power of 2, which is 3. Here we have 4 over 3 times 1 over 3. The two 3's become a 9, and our final answer is 4 over 9. That is our rate of change for the following parametric equation. And that is how to find the derivative of parametric equations.